When a billiard ball is shot at the rail and changes angles after it rebounds, the momentum changes in both the x and the y directions. In this problem, both the angle and the velocity change after the collision. So to find the change in momentum, we will have to analyze it in both the x and y directions. We are going to write our resultant momentum in component form. We want to get the velocity vectors from before and after the ball hit the rail. We want to isolate the velocity vector from before the collision first. We need to draw a vector triangle to find the x and y components. Here is the vector triangle of the ball before the collision. It has a velocity of 15 meters per second at an angle of 30 degrees in the first quadrant. Now let's do the same thing to the ball after the collision. We want to draw a velocity vector for the ball after the collision. The velocity of the ball is 10 meters per second at 40 degrees in the fourth quadrant. We now want to use these vectors to find the change in momentum in both the x and the y directions. We need to analyze the momentum change in both the x and y directions. Let's take a look at the x direction first. The change in momentum in the x direction is equal to the x component of the momentum after the collision minus the initial momentum. We want to rewrite the equation substituting in the mass and velocities for the momentum. The change in momentum equals mvx minus mvx naught, where mvx naught equals 15 cosine of 30, and mvx equals 10 cosine of 40. We will also need the mass of the ball given in the original problem. The mass is 0.2 kilograms. Now we can plug all of the numbers in for our variables. It's time to solve for the change in momentum in the x direction. The change in momentum in the x direction equals negative 1.1 kilogram meters per second. Now we have to find the change in momentum in the y direction. The change in momentum in the y equals py minus py naught. We will change the momentums into masses and velocities, allowing us to substitute in our numbers. Vy naught equals 15 sine of 30, and Vy equals negative 10 sine of 40. The mass is 0.2 kilograms, and these values can be entered into our formula. Now we can solve for the change in momentum in the y direction. Our change in momentum in the y is equal to negative 2.8 kilogram meters per second. We can now write our final answer in component form. And we have found the change in momentum of the billiard ball.